I hope everyone's doing well. Thank you for joining me for this video where we are looking here at a second order differential equation application involving current in a circuit. The electric current in a circuit is given by this second order differential equation that you see. You have a second order derivative with respect to current and your first order and your zero order. D square I over dt square, where t is your time, I is your current, plus 4 di over dt plus 2504 I is equal to 110. In essence, this is what we have. Your second order plus 4 times your first order plus 2504 I is equal to 110. We have boundary values. At time t equals 0, the current is equal to 0, but the first order derivative is also equal to 0. We have to find the current at time 3 seconds. That right there is our question. As you can see right here, find I3. How can we do it? Well, you know, from here you're looking at your complementary function, from here you're looking at your particular integral, so you should start by focusing on the complementary function first, and you treat this part right here, the left hand side, as a homogeneous equation. You know here your variables are i's and t's, not y and x, but i's and t's. You can say a certain function I is equal to e exponent rt, then the first order derivative is r e to the rt, the second order derivative is r square e to the rt, and you plug those right over here. When you do that, you'll have r square plus 4r plus 2504 is equal to 0, because you're treating it as homogeneous. Why did I not bring these exponentials? Because if you brought the exponentials, you would have isolated the exponentials from all of this. You'd have taken on the other side and it would have zeroed out anyway, so why even bring it in? The exponentials here are kind of meaningless because they zero out anyways. Only the r values are being evaluated. Now you have to factor this using your quadratic formula. You have a minus b, which is a minus 4, plus and minus b square, which is 16 minus 4a, which is a 1, and c 2504 divided by 2a. A here is a 1. Let's calculate this. You have here 2504 times 4, it's a minus, plus is 16. You're doing a square root of this, but you know that's going to be 100i. An imaginary number will come in. We have over here a minus 4 plus and minus 100i divided by 2. When we simplify it, we have a minus 2 plus and minus 50i. Complex conjugate solutions, a plus and minus bi. This right here is what we're getting as our solutions for this differential equation when you treat it as a homogeneous differential equation. Now what we have to do is present our answer here in terms of a complementary function, then we'll proceed from there. Our complementary function, you know the format. I'll show you the format right here, then we'll adjust it based on our variables. Y is equal to e exponent ax, then you have a cosine bx. This is when you have complex conjugates, plus b and then sine bx. Now the capital A and B are your constants, but the lowercase a and b's are that. You know what you could say over here in terms of your variables I and t, and bringing in the a and the b value is this. You have a I is equal to e exponent ax, which is a minus 2t, because your variables are i's and t's, not y and x's. Then you have a cosine 50t plus b sine 50t. This right over here represents your complementary function and it should be correct. Now we worry on the particular integral. Let's erase all of this because we don't need to see this anymore. You have here a non-homogeneous differential equation which is not equal to 0. It's actually equal to a function. That function is a constant. When you have a constant, you normally say y is equal to k, but since our variables here are i's and t's, t is your independent, your I is your dependent variable, you'll say I is equal to k. The first order derivative of that is a 0. The second order of that is 0. You put these values over here. When you do that, you have a 0 plus 4 times 0 plus 2504 I, which is a k, is equal to 110. You solve for the value of k. These zero out. You're doing 110 divided by this value, and let's do it. 110 divided by 2504, I have 0.0439. I round it up to 0.044. K here is equal to 0.044. And now let's look at what our overall general solution is. Our general solution over here is going to be equal to a certain complementary function plus a particular integral. Our particular integral is this, because it's so small, there's no real items which are being generated other than just a constant, because we started here with a constant. Here as you see on the bottom, is my complementary function. Now if I just do over here plus 0.044, that right here is our general solution. As you can see, I is equal to e exponent minus 2t times a cosine 50t plus b sine 50t, close the parentheses, plus 0.044. This part right is your complementary function. Here is your particular integral. Now let's look here at our question. Our question says to find the current at time 3 seconds, but we still have these constants here we have to do something about. We need those values. So how can we do it? Look here at your boundary functions. At time t equals 0, you have a current which is equal to 0, but you also have a first order derivative which you can say as di over dt, which is also equal to 0. So bring in these items here. You're looking here at an equation which involves I and t. So at time t equals 0, your current is equal to 0, and put zeros here in places of t's. I have e to the power of 0, then I have a cosine of a 0, then I have a b sine of a 0, then I have a plus 0.044. You know sine of a 0 is a 0, the b goes away, but you can easily calculate the value of a. 0 here is equal to e exponent 0, which is a 1. You have a cosine of 0 is a 1 plus 0.044. What is a here equal to? Push this on the other side, you have minus 0.044. And let's put that aside. We've determined this right at the value of a. Now we have to determine the value of b, and we will do so by our first order derivative, which is a value of 0 at time 0. But we have to do the derivative determination of this expression, and you have a product of functions right here. You have an exponential being applied in a product relationship with trigonometric, so it's a bit of a product rule coming into play. What is the derivative of this? Let's use a product rule. When you do the derivative of this I, it's this, but when you do the derivative of this constant 0.044, it's 0, it goes away. You just apply the product rule over here. You'll do e exponent minus 2t times the derivative of this, which will be what? Minus 50 a sine. You will be using the chain rule over here, but you can run this through your head. 50t plus the derivative over here, you'll be a 50b cosine 50t. This right here is my first part of the product rule, because you know the product rule is always xy prime plus y x prime. Your product rule, I've done like this right here. Now let's bring in the other part. In the other part, you do this times the derivative of this, which would be what? We'll do plus. I'll have a cosine 50t plus b sine 50t times the derivative of this, which I'm going to bring here at the beginning. It'll be minus 2e exponent minus 2t, and I'll bring a plus over here. Either way how you say it, but this derivative here is correct. Now you have to bring in these boundary values. At time t equals 0, I have this. We have to determine the value of b, and we will. You have to plug in your values. At time 0, the derivative was equal to 0. Put zeros in places of t's. This e to the power 0 is a 1. I want you to write it. Sine of 0 is a 0. That goes away. Cosine of a 0 is 1, but I have a plus 50b. This is here nothing other than algebra. You can do it on your own. You have to put t as 0. T of 0, this becomes a 1. T of 0, this zeroes out. T of 0, cosine of 0 is a 1. This is a 50b. Come down over here. T of 0, t value of 0, this becomes here a minus 2. Then you have cosine of a 0, you have a over here. Then you have a sine of a 0, and that b goes away. This is what you have to evaluate, but you know you have the value of a, which is minus 0.044, and you're solving here for b. Let's run this through our calculator. Focus right over here. I have here an a value of 0.044 negative. I'll multiply it with minus 2. I'll push this on the other side, it becomes a negative value. I'll divide it by 50 because it's a 50b. Divided by 50, this here will be my b value, minus 0.00176. But I can round it up to minus 0.0018. Nothing but calculator values. Minus 0.0018 is my b value. We will erase this clutter over here. The general solution will become our specific solution by plugging in the values a's and b's. Then we can actually determine I of 3, the current at time 3 seconds. Our specific solution will be this. The current at time t is equal to, you have e exponent minus 2t. Then I have a value here, which is a minus 0.044 cosine 50t. Then I have here a plus b, but b is a negative value also, so let's bring it in. Minus 0.0018 sine 50t. Let's close this out, and let's not forget that plus 0.044. The top part right here is coming from the complementary function. The lower part is your particular integral. Now you have this, but look, you can isolate these negatives and push them out. You can say your answer is this. By means of algebraic manipulation, I'm getting rid of these negatives, I'm pushing them out. I have a minus e exponent minus 2t. Then I have a 0.044 cosine 50t plus, because I'm getting rid of these negatives, pushing them out, they become positives, plus 0.0018 sine 50t plus your particular integral value, your constant 0.044. This here is your solution, but we have yet to answer the actual question, current at time 3. What we can do now is basically, for cleanliness purposes, get rid of this statement right here, because we just manipulated by means of algebra to write it in a better way without the negatives in here, but the negative pushed out here. Now we have to evaluate at time 3. You have to just put, in places of t's, you put 3, because we're determining I of 3. What is your current at time 3? This here will be calculator work. Here's your 50t, here's your 50t. It looks better that way. Now it's going to take a bunch of strokes to calculate this. Let's do it. Let's start from right here. Put your calculator on the radian mode. 50 times 3 will sine it. We'll multiply by 0.0018. I'll save this value. Now look, 50 times 3. 50 times 3 seconds. Cosine this value. Everything on RAD mode. Times 0.044. I'll add it to my saved value. I'm getting here 0.029. That's what I have. I'm putting it over here temporarily. 0.02948. Now focus right here on the exponential value. Exponential value with time t equals 3 seconds. I have a 2 times that 3, but it's a negative exponent. Activate the exponential. Bring in the minus outside, which is your coefficient minus, multiplied by my saved value, which was this 0.02948. I have here minus 7.3 times 10 to the minus 5. Added here to your constant, plus 0.044, and your answer will be 0.0439, and it should be correct. So let's erase this. Our current at time 3 is 0.0439, and you can say what are units, your amps, or you could say milliamps. It's not specified in the problem, but either or. But 0.0439 is the correct answer, and we'll go with it. So I'm happy with this answer here. Using the second order differential equation, the procedures for solving non-homogeneous, and these boundary values, we were able to convert our general solution into an actual solution, a specific solution, which you see right here. The constants were solved out. Using this expression here, then we were able to determine the current at time 3, 0.0439 amps or milliamps, whatever the unit might have been. But the question is done. Thank you for watching.